Hello and welcome to our first digital learning lesson. So I need you guys to take a few notes on this. Your homework tonight will be a widget. It's just one of the worksheets offered by the textbook that I put in widget form to make it easy for us to do digitally. Now today we're going to talk about experimental probability, and our goal is to find the experimental probability of a simple event. So one thing you might be wondering is, what's the difference? What's different from what we already were doing? So the big difference is that this is based on data instead of fair play. So based on data rather than fair play. So for example, theoretically, you roll a coin, you do it 6 times, you should get each of the 6 numbers. It doesn't always happen though. And then if we extrapolate this, if we apply this to other contexts like shooting a basketball, getting a hit in baseball, whatever it might be, it's not always 50-50, it's not always going to break, there's no real theoretical thing, it's just experimental. What's happened in the past, and we use that to determine what's probably going to happen in the future. So the way we'll define experimental probability is like this. We'll shorten it EP for experimental probability. It's the same principle, all right? We said probability is desired over possible, but what we're going to call it is the event, whatever the event might be. And notice it's the with a capital T or T there. So it's the event you want to happen, all right? It's you making a free throw, whatever it is, over all events. So every time you missed a free throw. And then a fancier word, a more statistically appropriate word would be trials. So the event that you wanted over all the events possible. That's experimental probability. So let's take a look at one of the examples from the textbook to see if we can make sense of this. So Martin has a bag of marbles. He removed one marble at random, recorded the color, and then placed it back in the bag. He repeated this process several times and recorded his results in the table. Find the experimental probability. Now, when it comes to experimental probability, we don't need to know how many of each there were. We don't need to know how many there were. Well, actually, we will need to know how many there were total. Or we don't need to know how many are actually in the bag total. But what we do need to know is how many times it happened overall. So the first thing to do is to add all these together. And if we do that, 12 plus 10 plus 15 plus 13, that gives us a total of 50. So it wants us to find the experimental probability of each one of them. And hey, how convenient. I have each of these colors right here. So if we're talking about the probability of red, we will take 12. That's the number of times we got the event we wanted over how many events there were total. 50. We can reduce that fraction to 6 over 25. That's the experimental probability. Let's try it again with blue this time. So blue occurred 10 times. And there were 50 trials, 50 events, and so that gives us 1/5. So again, just make sure you reduce the fraction as far as it can go. Now taking a look at green, there were 15 selected over a total of 50. In that one, we could take out a 5 to get 3 over 10. And finally, we look at yellow, 13 over 50, and well, that's about as reduced as that's going to get. So there's our final answer. So that's all we're doing today. Looking at what is the experimental probability. And again, it's the ratio of the thing you wanted, the specific event you wanted, over however many times this event happened. One more example. So here we have a spinner with 3 unequal sections, red, yellow, and blue. The table shows the results of Nolan's spins. Find the experimental probability of landing on each color. Write your answer in simplest form. So again, it starts off with, how many times did this happen? We'll add them all up. 10 plus 14 plus 6, that's 20 plus 10, 30 total. Okay, so we'll keep that in our back pocket. Then we just have to take a look at red, yellow, and blue. Red occurred 10 out of 30 times. That can be reduced to 1/3. Yellow happened 14 out of 30 times. That can be reduced to 7 over 15. And finally, blue happened 6 over 30 times, which can be reduced to 1 over 5. And there we go. That's all we have to do today, is find experimental probability. And again, we don't know, how many yellow sections, how many blue sections, red sections there are, and we're not counting the numbers or anything like that. We are simply looking at the data and making the probability from that. So homework tonight is to try the widget. All your answers will be given in fraction form. If you have any questions, please don't hesitate to email me. Best of luck.